Assalamualaikum and hi. Today, my friends and I are going to present about applied maximum and minimum problems. Before we start, let me introduce my friends. First, we have NURUL NATASYA ALIA BINTI ZAINI SHAH. Second, we have AMIRATUL Balqis BINTI SAUFI. Third, we have me, ADINATASHA BINTI CHAIRUL ANWAR. And lastly, we have QURRATU'AINI BINTI ZULKARNAIN SHAH. Let me explain about what is differentiation. Differentiation is a method of finding derivative or rate of change of a function. There are three techniques to solve differentiation. First is the sum and differences, second is the product rule, and third is the quotient rule. The rate of change function is dy dx equals to fx equals to y. There are 5 applications of differentiation, including related rates, analysis of function 1, analysis of function 2, maximum and minimum problems, rows and mean value theorem. Now, let's talk about applied maximum and minimum problems. What is it? It is a method of finding the maximum and minimum values, or also known as optimization. Why we use it? We use it to increase our knowledge about application of differentiation and to be able to understand and solve applied maximum and minimum problems. How to use it? We use it by finding the derivative, let the derivative equals to 0, and do the second derivative test. If the result is greater than 0, the value is minimum, whereas if the result is less than 0, the value is maximum.
Figure below shows a right cylinder closed at both ends has a radius s and height y. If the surface area of the cylinder is 150 pi cm square, write y in terms of s. So now we have radius equal to x and height equal to y. Given the surface area equal to 150 pi, and then we need to use the formula of cylinder with surface area. So we get 2 pi x square plus 2 pi xy equal to 150 pi. Next, we can isolate the term of involving y by subtracting 2 pi x square from both sides. So now we have 2 pi xy equal to 150 pi minus 2 pi x squared. Now we can divide everything by 2 pi x to solve for y. And now we have y equal to 150 pi per 2 pi x minus 2 pi x squared per 2 pi x. We can simplify this where we cancel out pi from the numerator and denominator. And now we have y equal to 75x minus x squared per x. So the expression for y in terms of x is y equal to 75 minus x squared per x.
Question B. Prove that the volume of the cylinder is V equal to 75 pi x minus pi x power of 3. Today we will derive the volume formula of a cylinder and prove that V equal to 75 pi x minus pi x power of 3. So we will use the given value of y in terms of x that we got from question A. Step 1. We know the formula for the volume V of a cylinder is V equal to pi r power of 2h, where r is the radius and h is the height of the cylinder. To simplify the notation, we will use x for the radius r and y for the height h. Thus, the volume formula becomes V equal to pi x power of 2y. We are given the height y in terms of x, so y equal to 75 minus x power of 2 divided by x. So step 2, substituting y into the volume formula. Step 3, simplifying the volume expression Number 1, distribute pi x power of 2 inside the parentheses. Number 2, separate the fraction into two terms. Number 3, eliminate x in the simplification process because it appears in both the numerator and denominator in the fraction. So we have derived and proved that the volume of the cylinder is V equal to 75 pi x minus pi x power of 3.
For question C, you need to find the value of x such that the volume of the cylinder is maximum. There's 3 steps to answer this question. First of all, you need to find the derivative, which is find the derivative of volume of the cylinder. Which is V equals to 75 pi x minus pi x power of 3 using the formula of derivative. So 75 pi x, the x is power of 1, so 1 times 75 pi will be 75 pi. Next, the negative pi x power of 3. X power of 3, we bring the 3 to the front, so 3 times pi x. The power of 3 will be minus with 1, so it will be x power of 2. So the derivative will be the dv over dx will be 75 pi minus 3 pi x power of 2. Next, we let the dv over dx equals to 0. We solve the solution. So we bring the 75 pi to the right side. It will be negative 75 pi. And the negative 3 pi to the right side. And it will be x power of 2 equals to 25. We only need the value of x. So we bring the power of 2 to the right side. It will be x equals to square root of 25. So the value of x will be 5. Prove the x is the maximum value. So from the dv over dx, we do the second derivative. It will be negative 6 pi x. Because since the 75 pi don't have x, it will be 0. So minus 3 pi x power of 2. 2 will be multiplied with 3. It will be negative 6 pi, and x power of 2 will be minus with 1. So x power of 1. That's why it will be negative 6 pi x. So we put the value of x inside the second derivative. So negative 6 pi times 5 will be negative 30 pi. We can see that the negative 30 pi is less than 0. So that's why x equals to 5 cm is a maximum value. Okay. Lastly, since we know the x value, we also can find the value of y. So we just put the 5 into the x in the y equation, which will be y equals to 10.
So, in conclusion, by applying differentiation method into this problem, we are able to perceive that by using application of differentiation, we can define the value of volume. Other than that, by obtaining the right formula and identifying both first and second derivative can lead to correct answer.